Dear students, yesterday we have studied about the Bohr atom model. That is, in Bohr atom model, we have studied the radius of the orbit. That is first orbit, second orbit, that is nth orbit, up to the radius of the nth orbit. Today we can see about the speed of electron in the hydrogen atom. That is, using that radius only we will find the speed of electron. That is, yesterday we studied equation 2, that is velocity is equal to nh divided by 2 pi mr. R means radius of the orbit, therefore R we know, that is equal to epsilon naught h square n square divided by pi m e square. Then you substitute the value of R in this equation, then what will you get? nh divided by 2 pi m into r, that is pi m e square divided by epsilon naught n square h square. Here pi gets cancel, n gets cancel, h gets cancel, then m gets cancel. Then what will we get? E square divided by 2 epsilon naught h into n. Then for n means first orbit, second orbit, third orbit, like that. Then if you put n is equal to 1 for first orbit, then the velocity of electron will be v1, that is equal to e square by 2 epsilon naught h. Then if you substitute the e, then epsilon naught and h, then you divide this with the speed of light, this velocity of electron with the speed of or velocity of light, then it is represented by alpha, that is alpha is equal to v1 by c, that is equal to, we will get 1 by 137. Therefore n, this is first orbit, the electron in the first Bohr orbit, it moves at 1 by 137 times the speed of light. Therefore this alpha, this is called fine structure constant. These are about speed of electron. Then next we can see about the energy of the electron in the nth orbit. That is, energy means here there are two types of energy, kinetic energy and potential energy. Then first this we have to find the kinetic energy, then potential energy, then total energy. From that we can find the energy. That is, kinetic energy of the electron is half mv square. Then the potential energy, it is due to the proton and the electron. Therefore potential energy is equal to 1 by 4 pi epsilon naught into electron charge minus e into nucleus charge is e divided by r. That is 1 by 4 pi epsilon naught can be written as k. Therefore this minus k into e square divided by r. Then we want to write the total energy, that is equal to half m e equal to half m v square minus k e square by r. Then this m v square you want to find and substitute here, then you will get energy. That is, we know the centripetal force, this is equal to the Coulomb force of attraction. That is, m v square by r is equal to k e square by r. That is, k means 1 by 4 pi epsilon naught into e square by r square. Then here r gets cancel. Then what will you get? M v square. That is, m v square is equal to k e square by r. M v square equal to k e square by r. Then you put this value in equation, this energy, total energy equation, that is equation 5. Then we get E is equal to half into k e square by r, that is m v square minus k e square by r. Then from this k e square by r is constant, take outside, then you will get what? 1 by 2 minus 1, that is 1 by 2 minus 1 is minus 1 by 2. Therefore we will get E is equal to what? Minus k e square by 2r. Then substitute the value of k is equal to 1 by 4 pi epsilon naught. Then this 4 into 2 is equal to 8, that is equal to minus e square by 8 pi epsilon naught into r. Then substitute here, r means radius of the orbit, you substitute the value of r, then you will get E is equal to minus e square divided by 8 pi epsilon naught into r equal to what? Epsilon naught n square h square divided by pi m e square. Then here you cancel epsilon naught then pi gets cancelled, then you will get what? M e power 4 divided by 8 epsilon naught square h square into 1 by n square, then minus. Here this is the energy of the orbit, stationary orbit. Then here from this we see that the energy is negative, then it is inversely proportional to the number of orbit, that is n square of the orbits number. Then when the energy increases, what happens? The orbit decreases, or when the orbit increases, the energy becomes what is 0. Then here the electron is most, that is when it moves, when the electron moves in a circular orbit, then the electron is most tightly bound to the nucleus. Then when there is a distance between the electron and the nucleus, then the electron is free of, it is not bounded to the nucleus. Then this allowed, this n equal to 1, 2, 3, then we get a spectrum, that is discrete values of energy E1, E2, E3, then we get a spectrum, that is energy level diagram. Then you substitute, that is n is equal to 1, then what will you get? E1 is equal to n is equal to 1, then you will get what? E1 is equal to minus m e square power 4 divided by 8 epsilon naught square h square into 1. Then you substitute the values of m, e, epsilon naught h, then you will get what? Minus 13.6 electron volt. Similarly, you put n equal to 2, then you will get what? E1 equal to that is minus 13.6 divided by 2 square, that is 4. Then you will get one value, that is 3.39 electron volt. Like this, n equal to 3 you substitute means you will get minus 1.51 electron volt. Therefore, when the system, from this we understood what means when the system is in the ground state, its binding energy will be equal to 13.6 electron volt. This energy is required to remove the electron from the atom. This is the energy required to remove the electron from the atom. The next is Bohr's interpretation of hydrogen spectrum. That is, in Bohr's interpretation of hydrogen spectrum, here we also, like similarly we have studied earlier, like that only, that is the electron making transition from the excited state of energy E2 to a lower energy state of energy E1. Then during this transition, the atom radiates energy, or it releases some energy, that is E2 minus E1. This energy will be equal to what? H nu. E2 minus E1 will be equal to H nu. Then we know the energy of the allowed orbit, we know from the above equation. En is equal to minus m e power 4 divided by 8 epsilon naught square h square into 1 by n square. Here you put n is equal to 1 first orbit, then second orbit n is equal to 2. Then you will find E2 minus E1. Then here E2 minus E1 if you find means the common term is what? M e power 4 divided by 8 epsilon naught square h square. Then you that is 1 by n1 square will be positive, then 1 by n2 square will be negative, that is 1 by n1 square minus 1 by n2 square. Then you know E2 minus E1 is equal to what? H nu. That is H nu is equal to m e power 4 by 8 epsilon naught square h square into 1 by n1 square minus 1 by n2 square. From this you find nu, that is you cross multiply h, then here it will become h cube. Then this gives the what? Frequency of, nu means frequency, that is the frequency of the spectral line produced during the transition of the electron. Then from this you find wave number, you know wave number nu bar is equal to nu by c. Then that is 1 c you substitute, that is m e power 4 by 8 epsilon naught square c into h cube into 1 by n1 square minus 1 by n2 square. That is nu bar is equal to this m e power 4 by 8 epsilon naught square c h cube. It is a constant, that is equal to r. This constant r is called Rydberg constant, that is r. Therefore nu bar is equal to r into 1 by n1 square minus 1 by n2 square. Then you substitute the value for r, that is m e epsilon naught c h. Then you will get what? 1.097 into 10 power 7 per meter. This is the value for Rydberg constant. Then from using this equation, that is nu bar, you can find the spectral series of hydrogen spectrum. This you have studied in lower classes. The spectral series, that is there are different spectral series: Lyman series, Bohrs series, Pearson series, bracket series, then Fund series. Lyman series means the electron it make transition from that is higher orbit to the first orbit. Therefore here you put what? N1 is equal to 1, and then N2 is equal to 2, 3, 4, etc. Therefore wave number nu bar is equal to this r into 1 by N1 is equal to 1 square minus 1 by N2 square. This is for what? A Lyman series. Then Bohrs series means the electron make transition from that is higher orbits to 3, 4, 5 etc. orbit to the second orbit. That is here n1 will be equal to 2, then n2 is equal to 3, 4, 5 etc. Then you substitute the values. Then Pearson series means the electron make transition from higher orbit 4, 5, 6 etc. to the third orbit. That is n1 equal to 3, n2 is equal to 4, 5, 6. Then you substitute the values. Then next bracket series means the electron make a transition from the higher orbits 5, 6, 7 to the fourth orbit. Like that, Fund series means they make a transition from the 6, 7, 8 that or higher orbit to the fifth orbit. Then next you see the spectral series of hydrogen atom, that is hydrogen spectrum. That is n is equal to 1, 2, 3. That diagram you see, that is n equal to 1, 2, 3, 4, 5, 6. Then different energy levels are given. Then the first Lyman series, that is from the diagram you can know, that is the electron moves from second, third, fourth, fifth orbit to the first. Like that, Bohrs series means electron make transition from 3, 4, 5, 6 to 2 second orbit. Pearson means 4, 5, 6 to third orbit. Then bracket means what? Fourth orbit, that is from 5, 6 they are coming to fourth. Then Fund means they are coming to the fifth orbit from higher energies. Then next Bohr said that if you use hydrogen like spectrum, here you include the atomic number Z, that is atomic number Z. Therefore we get the force of attraction between, that is nucleus of charge E we have studied. Then you put atomic number Z, ZE. Then the electron of charge is minus e. Therefore, one force of attraction is 1 by 4 pi epsilon naught Zt into minus e divided by r square. That is minus 1 by 4 pi epsilon naught into Zt square by r square. Similarly, the wave number also there you put for nucleus. Therefore, Z square. Then here you can put the nu bar is equal to 1 by lambda. For this you put capital R Rydberg constant into this Z square into 1 by n1 square minus 1 by n2 square. This gives the wave number. This agrees with the experimental result. The next is the failure of Bohr theory. This Bohr theory, it does not explain about the variation of mass of the electron with velocity. Then it does not explain about the intensity of the spectral line. Then it does not explain the spectra of atoms having more than one electron. Then it does not account fine structure of spectral lines. That is, fine structure means a single line is splitted into large number of lines. That is, it does not give about the fine structure of spectral lines. This is the failure of Bohr theory.